What does it mean to see the unseeable? For decades, astronomers dreamed of capturing an image of a black hole, one of the universe's strangest and most powerful phenomena. Yet, for most of human history, a black hole was less a scientific image and more a whisper in the shadows, a concept at the edge of theoretical physics, impossible to photograph, puzzling to even imagine. And then, that first image appeared. To explore what it took to bring the invisible into view, let's begin with some words from a poet as old as language itself. I am a part of all that I have met, yet all experience is an arch where through gleams that untraveled world whose margin fades forever and forever when I move. Tennyson, Ulysses. Even with all our discoveries, there's always something just out of reach, something that pulls us forward. The black hole is perhaps the perfect embodiment of that unreachable margin, a region of space-time so dense and warped that not even light can escape. And yet scientists found a way to see it, but not in the way we see everything else. What is a black hole, anyway? The term might conjure images of a cosmic vacuum cleaner, sucking everything into oblivion. But a black hole is really a region where matter has collapsed under gravity so intensely that it forms a singularity, an infinitely dense point surrounded by an event horizon. Cross that event horizon, and you're lost to the universe. Light, information, everything, gone. But if nothing escapes a black hole, how could we ever see it? That's the puzzle that haunted even the greatest minds. Einstein's equations predicted that black holes should exist, but even he wasn't convinced that nature would allow such an absurd thing. For decades, black holes remained a mathematical oddity until evidence began to pile up in the form of mysterious X-ray sources and fast-orbiting stars near invisible centers. Still, an image is something different. Not a reading on a graph, not an inference from data, but a picture, a cosmic snapshot that makes the abstract startlingly concrete. The race was on. Could we build an eye big enough and sharp enough to glimpse the edge of a black hole? To approach that question, let's revisit another fragment from antiquity. What is it that binds together the things that are and separates them from the things that are not? The answer is, in some ways, information, and in the case of the black hole, information that seems to disappear. Yet astronomers realized that while the black hole itself emits no light, the matter swirling around it does. Superheated gas, bent and contorted by gravity, emitting radio waves as it spirals to oblivion. If we could catch those waves, map their patterns, and stitch them together, maybe we could see the shadow a black hole casts on the glowing chaos around it. But there were immense challenges. To resolve details as fine as the shadow of a black hole at the center of a distant galaxy, you'd need a telescope the size of Earth. But building a single dish that big isn't just hard. It's impossible. The answer lay in a technique called very long baseline interferometry, synchronizing telescopes across the globe so that each one collects a piece of the story. Each observatory is like a little eye, but when their data is combined, it's as if we've built one planet-sized super eye. Let's borrow a line from one more ancient source. To see a world in a grain of sand and a heaven in a wildflower, hold infinity in the palm of your hand and eternity in an hour. It's a kind of modern alchemy, turning a globe-spanning network of gadgets and wires into a tool that sees into infinity. In 2017, telescopes in Hawaii, Spain, Chile, Mexico, Arizona, and near the South Pole all pointed at a single spot in the sky. The object, a supermassive black hole, 6.5 billion times the mass of our Sun, lurking at the heart of galaxy Messier 87. Data was gathered across thousands of miles, collected on hard drives flown to supercomputers, with algorithms devised to stitch together a meaningful image from the partial glimpses. All of this balanced on the edge of physics, mathematics, and hope. Months of analysis, countless equations, new methods to account for atmospheric distortion, hardware errors, even quantum uncertainties. And then, a picture appeared, a glowing ring of fire encircling a dark shadow. The shadow was the silhouette of the black hole's event horizon, a direct image of something once thought impossible to see. Pause for a moment and consider what this means. For centuries, black holes were ideas, unseeable monsters lurking at the edge of theory, a shadow in the mind. Now, suddenly, there was a photograph. What does it feel like to witness the universe revealing one of its deepest secrets? Maybe the answer is found in the words of Maya Angelou, who wrote, "We are more alike, my friends, than we are unalike." Humans across continents joined their minds and machines in a common act of curiosity. That black hole image isn't just a scientific triumph. It's a symbol of collaboration on a planetary scale. Scientists in dozens of countries working together for years to make the universe a little less mysterious. But what is the image, really? It isn't like a snapshot with a phone. It's the result of combining huge streams of radio data, run through complex mathematical models to recreate what light would do orbiting near a black hole. They even ran fake data through their computers to foolproof their approach, making sure they weren't just seeing patterns and noise. It took weeks to physically move the storage drives. So much data that it was faster to fly the drives than to beam the results through the internet. What we see, the ring of light, isn't light coming from the black hole, since nothing escapes its gravity. It's the furious glow of matter heated to billions of degrees, racing at nearly the speed of light, warped into a crescent by the intense pull of gravity. The image is a testament to both the violence and the beauty of the universe. What comes next? Now that we have a photograph of a black hole, what do we do with it? For physicists, it's a tool to test Einstein's theory of gravity at its most extreme limit. For astronomers, it's a window into galaxy formation and evolution. For ordinary people, maybe it's a reminder that humans can tackle even the wildest mysteries. Together, to reflect on this achievement, consider these words from the Upanishads. From the unreal, lead me to the real. From darkness, lead me to light. From death, lead me to immortality. The journey to see the black hole has all those elements, turning abstract mathematics into something real, moving from the darkness of ignorance into the light of discovery, taking a phenomenon associated with death and oblivion and granting it a kind of immortality, recorded in an image for the world to see. And yet, with every answer, more questions arise. Does the event horizon really mark the edge of space-time as we understand it? What's inside, if anything? Will new images of other black holes reveal surprises, tricks, perhaps even cracks in our ideas of how gravity works? In some ways, the photograph is only the beginning. Now the quest is on for sharper images, movies showing matter in motion, even peering at the central black hole of our own galaxy. Every advancement pushes the technical and intellectual limits of our species. And each time, the black hole seems at once a little more familiar and more strange, too. Let's recall the lines of the astronomer Carl Sagan. Somewhere, something incredible is waiting to be known. With the first image of a black hole, we have crossed one boundary of the unknown, but there will always be others. And so, the race isn't truly over, it's just changed shape. As humans, we are driven to explore, to look where eyes cannot go, to make the invisible visible. The first image of a black hole is a monument to that drive. And ultimately, the black hole's photo mirrors our own curiosity. The closer we get, the more the horizon slips away, inviting us to see further. So, what's next? That's up to all of us, scientists and dreamers, builders and thinkers. The universe is waiting,